Hello, good morning. How are you? I hope you are well. I'm sure you are well. I missed you and I hope you miss me too. So as you can see me, I am well. The only thing I'm gaining some weight, but I try to do some sports. I hope you do some sports too. And when we meet together again, we can have a nice moment. And okay, I hope you are ready to learn how to do this type of equations with brackets, okay? See, this is one of the examples you have for homework, and this is what we are going to see now. First, as you can see here, when you want to operate, you find that there is a bracket. Then when you have brackets, the first thing you have to do is to remove the brackets by applying the distributive property, because you cannot operate. How do you apply the distributive property? You have to multiply the number 3, and there is a point here. We have to multiply 3 times x and 3 times minus 2. This is what we have to do, okay? And copy the rest. So x plus 10 equals 2. 3 times x is 3x. That is 3 times x2, right? 3, which is positive, times minus 2 is negative 6. So now we have an ordinary equations and you know how to do it. What is the next time you have to do now? The next time you have to do is to have all x terms on the left or numbers on the right. To do this, you have to do it by adding or subtracting the same value to both members of the equation so that you get an equivalent equation. For example, what do we have here what we don't want to have? The number plus 10. And here we have the plus 3x. So what we have to do is to subtract 10 to both members of the equation. When we subtract 10 here, we get 0. When we subtract 10 here, we have minus 10. What else? Subtract 3x to both members of the equation. We subtract 3x here, we get 0. If we subtract 3x here, we have minus 3x. And now we copy the rest, which is minus 6 and x. So now we have x minus 3x equals minus 10 minus 6. Some people says that to eliminate this plus 3 here, you passes to the right member changing the sign. Or to eliminate this 3x, which is positive on the right member of the equation, we passes to the left side changing the sign, which is not bad. But you have to do it knowing that what you are doing is to add or subtract the same value to both members and getting an equivalent equation. An equivalent equation is an equation with the same solution to the original one. Now we are here. What do we have to do now? We operate. They are like terms. They are similar terms. So you have x minus 3x equals minus 2x. And here it is minus 10 minus 6 equals minus 16. Good. Now we have to isolate the variable. How do you isolate the variable? Now is the moment to divide both members of the equation by the coefficient of the x. The coefficient of the x is negative 2. So you divide both members of the equation by negative 2. When you divide this member by negative 2, you have x, because minus 2x divided by negative x is x. And negative 16 divided by negative 2 equals 8. Some people explain this by saying, okay, this negative 2 that is multiplying the x change to the right member of the equation by dividing the number minus 16, which is not bad. But I repeat, what you really do is divide both members of the equation by the same number, getting an equivalent equation. Okay, now we get the solution, x equals 8. So we think that x equals 8 is the solution of the equation. What is the solution of the equation? The solution of the equation is the value of the variable that makes the equality true. And this is what we have to check now. To check now this, I'm gonna delete. Have you copied? If you haven't copied, you can go back to the video because it is a video now. Okay, how do we do it? We substitute 8 in x in all parts of the equation. So here you have 8 plus 10, and here you have 3, 8 minus 2. Okay, now here we can operate. We don't need to apply the distributive property. We can operate. We say 3 times 8 minus 2 equals 6, and 8 plus 10 equals 16. 18. So, as you can see, 18 equals to 3 times 6. So 8 is the solution of the equation. With this, we have finished. And that's all.